Hello everyone, welcome to Lab 4, which is about oscillations. Newton's second law of the momentum principle states that the change in momentum of a system means that there's a net force. This is nothing new. However, when we apply this to a spring, we can actually observe oscillating motion. An oscillating motion typically follows cyclical and predictable patterns, which we can analyze in both the x-axis and also the y-axis. So in this lab, what we're going to do is we'll put a mass on a spring and we'll record a video of it. Then we will analyze it and make a computational model of it. So here's the purpose of this experiment. The purpose of this experiment is to observe the motion of a mass on a spring with motion in the x and y directions. Then we will create a computational model of this motion in GlowScript, where we'll take data from our video and put it into GlowScript and see what it gives us. And then finally, we will compare expected and observed motion, one from the GlowScript and one from the actual video data. Here are most of the equations that we will utilize inside of this lab. There are many of them, including the velocity update, position update, gravitational potential energy, spring potential energy, as well as spring force, kinetic energy, and the period formula of oscillations. Now, we will utilize all of these throughout the lab, and not only inside the code, though a majority of them will show up inside of the code. In fact, as you can see right here they are. A vast majority of them are here, where we take the velocity update formula and the position update formula up top. Then we see all of the energy calculations on the bottom, including the kinetic energy, gravitational potential energy, and also the potential energy found within a spring. So from the tracker software, we can extrapolate these x and y values with respect to time. And from this data, we can gain some very important information, such as the period by dividing the time for cycles divided by the number of cycles. And also from that, and utilizing the time for oscillation formula, we can derive the spring constant, which is 6.09 newtons per meter. What were some improvements that we could have made to this experiment? Well, for one, the calibration on the tracker may have been a little off, and there was a failure to consider drag and other external sources such as heat transfer that would have changed the motion and the forces within the system. One thing we can do with the data obtained from this experiment is to analyze the period along the x-axis and also along the y-axis. One thing you'll notice is that the period within the x-axis is approximately 1.2 seconds, and along the y-axis is 1.6 seconds, which is interesting because they are a little off, as you would believe that they should be a bit closer. This shows us that there was definitely some sort of a calibration error, or just the clicking went wrong. Another thing we can analyze is whether or not the energy principle was actually satisfied in this experiment, and I would argue that yes, it was. By graphing the energy in the spring, we see that there is a fairly constant energy. So in conclusion, this experiment, we apply Newton's second law to a system with a mass. However, the expected model actually failed to match the observed due to likely drag heat or just human error. We also got to see sinusoidal motion. Nice.